Hello and very warm welcome to everyone. My name is Harjasleen Kaur and we all be representing Group D. Today we're going to discuss about the project for DAT604. The focus of our project is to use machine learning for predicting whether a customer will subscribe to a long-term deposit product based on the data from a bank telemarketing campaign. So let's get further into the introductory part of our project. So, in a competitive marketing industry, targeting the right customer is the key. This project uses a real telemarketing data and four machine learning models that are neural network, naive Bayes, K nearest neighbors, and decision tree in order to predict the long-term deposit subscriptions. The report aims to find the most effective predictive approach by exploring, preparing, and modeling the data. Beyond building models, it transformed the raw data into the real business value through a structured and data-driven methodology. So next up, these slides provide an overview about the project's objective. The primary objective of our project is to build and compare the machine learning models and to predict the customer subscription behavior. By doing so, we aim to enhance the marketing efficiency and reduce the unnecessary outreach. So after discussing the primary objective of our project, now we're going to answer the most important question, why it matters. So as we know in the banking industry, telemarketing is often a resource intensive. By accurately predicting which customers are more likely to subscribe, we can improve the conversion rates by focusing efforts on most promising leads. We can reduce the marketing cost by minimizing wasted outreach, enhancing the customer experience through more personalized and relevant communication, and support the data-driven decision making by basing the strategies on more predicting insights rather than guesswork.
Hello everyone, my name is Mansi and my student ID is 20239389, and today I'll be discussing about data source and scope. So dataset, it contains over 4100 records with diverse information like age, job, education and past contact history. Our task is to predict whether the customer subscribed based on these attributes. So, next slide is about tools and technologies used. So, the following tools and technologies were used are Python and scikit-learn. So, basically, scikit we used for data processing and model development. And scikit-learn, it helped us to implement multiple machine learning models for comparison. And Python, it basically has pandas, seaborn, and matplotlib, and scikit-learn basically have ML models. So next slide is data exploration and dataset overview. So basically data exploration is foundation for understanding the structure, quality and patterns in the data set. So initial exploration showed no missing values. The dataset contains both numeric and categorical values, which we needed to encode for compatibility with ML models. And categorical values were labeled encoded. The dataset was split into 80% training and 20% testing sets. This helps ensuring that our models can generalize well on unseen data. So now coming to our next slide, which is using Google Colab to upload the Excel file A2 data Excel SX. That PD reads Excel reads the file into a pandas data frame called DF. So DF head shows the first 5 rows of the data set. And if you want to view more number of rows, you can put I equals to value inside DF head. And missing value analysis, a full check using DF into confirm that no null or non values are present into the data set, and missing values indicates incomplete or corrupted data, and if not handled, that can mislead your analysis or cause model errors. Example, a model might treat missing income as zero and misclassify the customer as low income even though the data is just missing. Thank you.
Categorical variable contains text values such as job titles, education levels, or marital status. Since machine learning models require numeric input, these variables must be transformed into numbers, a process known as encoding. In this project, label encoding was used to convert all the categorical variable into numeric form. This approach assigns a unique integer to each category with a column. For example, different job types like admin services and the technician are mapped into numerical values like 0, 1, and 2. The target variable subscription, which has values yes and no, was also encoded as 1 and 0, respectively, to make it compatible with classification algorithms. This step ensures that the entire database is in a numerical format, making it fully compatible with the machine learning models used later in the project. Label encoding is efficient and works well with algorithms that do not assume any particular order in the data, such as decision trees and naive Bayes. With encoding completed, the database is now prepared for training and testing the models. Training set 80% used to train the model. This portion allows the model to learn patterns, relationships, and decision rules from the data. Testing set is 20% used to evaluate the model's performance on unseen data. It simulates how well the model would perform in real world scenarios. This 80 by 20 split is a commonly used standard in machine learning to ensure balanced learning and the favor evaluation. Train test splitting is a standard practice in machine learning. It prevents overfitting and helps in accurately measuring a model's predictive performance. Outcome after splitting. After splitting, the training test is used to fit models like neural network, decision tree, naive Bayes, and KNN. The test set is reserved for comparing predictions against the true labels, allowing us to objectively assess each model's strength. Model building. In this phase, four different machine learning classification models are developed to predict whether a customer will subscribe to a long-term deposit. Each model is trained using the same training dataset to ensure a fair comparison of their performance. Training approach. All the models were trained using the same pre-processed training data from the 80 by 20 split. The models were built using scikit learn libraries. Hyperparameters were kept simple. Example, default max enter, default n, neighbors equals to 5 to ensure consistency and avoid Bayes. Categorical data was already label encoded before training. Numerical values were used as in because models like decision trees, naive Bayes are not sensitive to scaling. Purpose of the model building is to evaluate which algorithm performs best on this binary classification task. To understand how each model reacts to class imbalance and categorical feature encoding. To build a prediction system that can be developed for business, use example generating a list of likely subscribers.
Hi, this is Zivan. I would like to continue this presentation with the topic neural network MLP classifiers. So, a neural network was used to capture the non-linear relationships in the data. It consists of an input layer, one or more hidden layer, and output layer. And MLP is ideal for learning complex patterns, especially when its features interact in a non-obvious ways. Now, let's move on to the next slide. So in this slide, we'll be discussing the decision tree classifiers. A decision tree algorithm was selected for its simplicity and ease of interpretation. It works by splitting the data into branches based on features, values that generates a tree-like model. Each internal node represents a decision and each leaf node corresponds to an output class. After training, the model was trained using the training dataset. Decision tree also worked well with both categorical and numerical features and do not require a feature scaling. Okay, moving on to the next slide. We'll be talking about naive Bayes. So naive Bayes is a probabilistic classifier that applies Bayes' theorem with strong assumption that features are independent. So we'll be discussing about the features being independent, and despite this assumption, it often performs well in practice and is extremely efficient. So the Gaussian naive Bayes classifier was successfully trained, and it assumes that the data follows a Gaussian, also known as a normal distribution. This model is particularly useful when fast predictions are needed. Okay, moving on. So in this slide, we'll be talking about evaluation metrics. So after training the four classification models, each was evaluated using the test dataset, 20% of the dataset. And this step assesses how well each model performs on unseen data and helps determine which model is suitable for deployment. Now to measure the performance for widely used classification.
Hello everyone, my name is Parminder Singh. My student ID is 202374988. Let's move to the 17th slide, which is based on the model performance summary. And the model specific observation neural network highest accuracy but lowest recall, strong at predicting the majority class but misses many true positives. Not optimal when identifying all possible subscribers is the goal. Decision tree balanced performance across all metrics, reasonable precision and recall, good interpretability, suitable for business decision maker. And next is native wire best recall, meaning it identified the most actual subscribers. Lower precision lead to the more false positive, ideal when the cost of missing a subscriber is high. The next is K nearest nearest highest F1 score and accuracy, best overall balance between precision and recall, effective in terms of actionable prediction for marketing strategies. Strategic interpretation, if the business goal is the maximize subscriber detection, native wire is a strong choice due to its recall. If the goal is balanced, high performing model, KNN provides the best overall performance. For explainable results, decisions tree is preferred. Let's move to the final model deployment, predicting likely subscribers. After comparing all the models, we now deploy the most suitable model to identify which customer are more likely to subscribe to a long-term deposit, that convert the analytic insight to a decision support tool for target making. In this project, we proceed with the K nearest nearby or neural network, depending on evaluation priority. For demonstrating, we use the neural network model, which was already trained earlier. Let's move to the output slide, predicting possibilities and label. The trained neural network predict both a binary label, a probability confidence score for each customer subscribing, combining with the test set, merge predict label and probabilities with the original test data. This give a complete view of each customer likelihood, filter likely subscriber, select only those customer who are predicting label 1, sort by predicted probability, rank the subscriber in descending order of probability, and the highest, the top customer to be contacted first, and decode for human readability, reserve the label encoding applied earlier, make the output interpretable for the business and marketing teams. Let's move to the next slide, which is deployment goal. Generate a ranked list of customer predicted to subscriber. Focus on those with the highest probability of conversion. Help the business prioritize outreach, reduce cost, and increase conversion rate. While leveraging the model prediction, marketing effort can be optimized. This result is in better ROI, lower campaign cost, and overall smarter business strategy. Let's move to the last slide, which is conclusion. A prediction was made using a machine learning models given which customers are most likely to subscribe to a term deposit. The best balance of result with good accuracy and strong performance were given by K nearest, which we call KNN. The model is used by the bank of concentrated effort on the right type of customer, making marketing cost fall and success percentage raise. Ultimately, this project provide the smarter use of data can be result in faster, cheaper, and more effective marketing. Thank you.